Thank you for the introduction. So, as it has been said, I'm the CTO of Satoshi Labs, which is a company that brought you Trezor. We've been doing Trezor since 2012, so it's quite a long-going effort now when it comes to compare to other Bitcoin or cryptocurrency projects. But this talk will be not about Trezor, like it usually is, but it will be about crypto space in general and what to do and what not to do. So my talk is called Security or / Insecurity of Crypto Space. And security of data has never been more important. When you lost some data like 20 years ago, it was usually some photos from vacation. It was sad, but it was not fatal. Today, usually when you lose some data or somebody steals your data, when it comes to data related to crypto space, this is fatal. You don't have access to your money, or somebody else has already stolen them. So there are various threats, and of course there are various methods how to avoid these threats, and we will go through these types and hopefully give you some advices what to do and what not to do. So there are data thefts, protocol errors, implementation errors, hardware attacks, political attacks, and we will go one after each other. So, data theft. This is nothing new. You probably know that in 2011, Mt. Gox exchange was hacked via security breach. 500,000 bitcoins were stolen. Then BTCE 2012, Poloniex 2014, BitPay. There was something interesting about this attack, that it was not like a regular security breach, it was a social engineering fraud when somebody pretended to be a chief finance officer of the company, and he wrote to the CEO, please top up our hot wallet, this is the address, and he happily did that. But it's also something like a security breach. And Bitfinex 2016. What these things have common is that they really are not tied to just the crypto space. Like this kind of attacks happen outside of the crypto space as well. So that's why I'm not going to go in further. I will focus on attacks that are mostly just specific for crypto space. But I will give you some takeaways anyway. For each section, there will be 2 sets of takeaways. If you are a developer of such thing, there is one set, and if you are a user of such thing, there is another set. So if you are developing a service, please use secure operating systems. I don't think that needs any further comment. Use second-factor authentication for accessing your infrastructure. That's very important, because attackers can deploy codes without you knowing it, and that's a big problem for your user, of course. Then provide second-factor authentication also for your users, so they can access your service securely. SMS is not a second-factor authentication, because you can get easily hacked when a mobile operator collaborates or is attacked on the really low level of this infrastructure. And also, it's quite good to hold regular meetings in your company to challenge your security protocols, like meet and have a discussion, like, is everything we do like correct? Like, isn't there any possibility? And it has proven to be a really good thing to, one thing is to create some security protocol, but then you have to constantly challenge it yourself, like if it's still good. And also, I think there's a good point, and nobody really talks about it. Socialize with your coworkers so we will know them better. Like if a CFO of your company sends you an email, hey, please do this, and you know him like really well, and you are like, it's probably not him, like what he's doing. So trust is fine, but if you exactly know what the other person does, it's even better. And for users, So use services that follow these security practices and others. Use these security features. If they are provided by the services, then use it. Read blogs, follow the ecosystem, and educate yourself so you'll know which service is good or bad. Then we have protocol errors. These are errors in design of the cryptographic protocol, and they are mostly logical errors by omission. Like the designer of the protocol haven't thought about that particular eventuality that hackers came up with and exploited. There is a problem that these errors are not tied to a particular implementation and impact all clients that implement this protocol because they are just doing what the protocol does. One good example is transaction malleability. It was a big thing like 2 or 3 years ago. So how does it work? Transaction ID is a hash of the transaction, including the transaction signatures. But for every ECDSA signature, which is a tuple of 2 numbers, R and S, the signature R minus S is also valid. It's the same signature, but it's a different number, and this number has a different representation. Also, if you pad these 2 values from left with zeros, the value doesn't change, but the representation in the computer changes. Like it's no difference if I give you 4 apples or 0, 0, 0, 0, 4 apples. So the transactions with the same meaning have different IDs. They have basically the same signatures and the content is the same, but this signature have different representation in the computer, so transaction ID is different. And this can lead to double spends. Like one part of the network thinks that this hasn't been spent because it sees a different transaction ID. So this was solved by tightening the rules for S. So the other minus S signature was no valid anymore. And also we use canonical DARE encoding. So there is a rule, like if a number starts with numbers with several zeros, then it's not a valid number because they are really not needed there. Then we have implementation errors. So these are errors in implementing the protocol. And these usually affect only one implementation. But we have open source today, and open source really encourages code reuse. So usually you have like open source library that is used in lots of projects. So even if one implementation is affected, all these projects that use this library are affected as well. And also, this open source encourages code reuse also between languages. For example, if I am writing some Python code and I found a JavaScript version on Stack Overflow, I will just rewrite it blindly. And that's, of course, not very good because I also copy not only the code, but also this implementation error. So that's what I said. There are a couple of really nice examples. Well, nice for us, but not nice for people that encounter them. So first of them is black hole. Basically, coins are sent to destinations where no one can spend them from. If you are using Unix, then devnull is something that is being compared to. So who recognizes this address? Okay, only one. So that's address in Bitcoin address that has like empty pub key hash. In Bitcoin, you have a public key, and then you hash it, and then you convert this hash to address. If something fails in the process, like for example, hash function says like, I cannot do this, it returns zeros, but if you don't check for the error code and work with the result again, we will end up with this address. So how much Bitcoins are on this address today? What do you think? No, it's not 2,000, but it's 60 Bitcoins, so it's $250,000. And it was happening all over the years, people sending Bitcoins there by accident, because it was not their fault, but the implementation fault of the software they were using. A similar case is this address. Does someone recognize this one? So it's a similar story. If you have a public key of 0, which is not a valid public key, it probably some ECDCA library told like, there was an error and I'm returning 0. And if you hash it and convert it to address, you get this address. And there are like 4 Bitcoins today. But it has lots of transactions, I think even more than the first one. Then there are weak random number generators. So if you are doing ECDCA signatures, it needs a strong random number to create a signature, because that's how it was designed. But if you have 2 different messages and you are assigning them with the same private key, and for some reason the random generator always gives you the same number, then your private key is compromised. Just by signing 2 different messages with the same key and same random number. By the way, this is how PlayStation 3 was hacked, because they had a weak number generator and they were signing games. So there were a lot of signatures out in the world, and they were able to perform this hack. But this will not happen because the space is just too big, right? Well, PlayStation has shown that it's not too big if you have a weak random generator. But we are talking about CryptoSpace. And unfortunately, exactly the same thing happened in Android in 2013. The interesting thing was that the author of the Bitcoin library for Android, they decided not to use their own random generator, but used the secure random generator from Android, which turned out that it was not so secure. So I think all 4 Bitcoin wallets for Android at that time were affected, and around 60 Bitcoins were reported stolen at that time. Then the smart people came with something that's called RFC 6979, deterministic signatures. And what they do is they say, let's not generate a random number k, but let's create a function that takes a message and a private or secret key and generates a random number from these 2. And this basically guarantees that you cannot generate same random number for different messages when the same private key is used. So this we used immediately in Trezor since the beginning, not only because of the Android fail, but we are unit testing our crypto library from top to bottom. And unit testing is really impossible when signatures always keep changing. Like you will give the same input, like same private key and same message, and it always returns a different signature. So that's why we decided to use the deterministic ones. And suddenly all the ECDSA crypto code was testable. But then, even after Trezor was out and everybody knew that RFC 6979 is the way to go, Bitcoin.js was affected. And some other projects like Counterparty or even Blockchain Info were using this library, so they had the same problem. And the problem with this is everyone can see that you messed up because the signatures are public in the blockchain. So I can just look into the blockchain and wait until you make a mistake. And there were some people in the world that were doing this. And one of them was Jochen, sitting somewhere there. And what he did, he preemptively swapped such coins from the blockchain info and stored them in Trezor, and then sent this picture to blockchain and to affected people, like he didn't know who they were, and said like, your Bitcoins are in this Trezor, and if you prove the ownership of that affected address and give me a new one, I will send them back. So that's... yeah. So that was our first contact with Jochen, and we've been collaborating happily ever since. He's doing a lot of stuff for Trezor, like you will see on the next slides. But there was one particular company that thought, like, you can't have weak random number generator if you don't have any. So what they did is, yeah, it was a blockchain again. So they had an Android wallet, and they said, what if we used, spoiler alert, so I will get back to this. So what we use this web service, random.org API, which generates random numbers. So we don't have to implement any, and we are safe because random work, like, it's very, very safe. But what happened is they switched to HTTPS, and suddenly this HTTP URL started to return this. And what they did, like, they always just hashed the response and used that to generate address. So suddenly, all requests were hashed to the same data, and when you converted this hash to the address, it was this. There were like 45 bitcoins on this address. Of course, they were like immediately swept away. And basically, a lot of people suddenly saw a new address in their wallet, which was exactly like this. So then there is another group of implementation errors which were introduced in Bitcoin Unlimited. And they had some memory leaks triggered by specially crafted user inputs or transactions. So I could create a transaction which was broadcasted to the network, and when it hit the Bitcoin Unlimited node, it started to eat a lot of memory, and then the kernel says, like, hey, but Bitcoin Unlimited, you use a lot of memory, I'm going to kill you. So that was a problem. And another problem a couple of weeks later was discovered that there were so-called reachable asserts, again, by specially crafted user inputs. So let me tell you a little bit about how that works. So in some programming languages, like for example Python or C, there is a thing called assert. And basically a programmer says, like, this condition, which I write here, like for example, block size is always less than 1 megabyte, should be always true. And if it's not true, so the assert is like broken, just don't continue and abort the whole process. This code, this assert is usually used in development build, but it really makes sense to use it for production build of such a system like Bitcoin as well, because you don't want to have code which uses the data that programmer didn't really anticipate it. So it's probably better to just shut down the node than to keep it running. If you have a game, it's a little bit different. Like if there is a broken texture, you can still finish the level and then restart the game. It's not a problem. But for Bitcoin, you don't want to keep it running if there is some inconsistency. So, but even if you are using these asserts in production code, there should not be like a path from user-defined input how to trigger this condition. And that's what was possible in Bitcoin Unlimited. Again, some hackers, they created special transactions which, after processing, trigger this path. And you can see there is the graph of the node count. So I think that this first fall was this memory leak I was talking about, and these two falls, it was like from 700 nodes to almost 200. So like 2/3 of the network were just down because of that particular hack. So then we have smart contracts. You probably knew about parity multisig problem. Parity is a client for Ethereum, and they had implemented a multi-signature contract, but there was an error. You probably also know about the DAO. I will not go into the details because it's like maybe topic for a separate talk, but there is a nice write-up by Vitalik here about how we should really rethink smart contract security. And the code is low, unless it's not. So For some problems, they decided just to somehow roll back the actions. I don't really want to go into the politics, but study it. It's a fine reading. So, some takeaways. If you are a developer, always peer review your code. Don't blindly copy-paste the code unless you understand it first. Don't use languages which make it easy to introduce bugs. So PHP, JavaScript, C, and basically every other language. Don't use them. But if you have to, follow the best practices. So for some languages like Perl or JavaScript, you can enable strict mode, comment code, so others have a bigger chance to understand in the code review. And if you are users, avoid using solutions with no or short or bad records, so you cannot judge what's the quality of the code. Look how active is the developer community around the project, because if it's very active, then probably the implementations error are, I'm not saying they are not there, but there is a high chance they were fixed. And also look how developers react to constructive criticism. Like if they are in denial, then run away. There is another section, hardware attacks. So you can have get good protocol and it's flawless implementation, but there are hackers that are still able to attack the underlying hardware, which is performing this code. And if they understand it very well, they could make it perform what they want, not what you want. Trezor is open source, both hardware and software. And because it's open, it attracts a lot of hackers. Not only the good ones, but also the bad ones. The good thing is that white hat good ones are winning. So we received some security reports in the past, and we were working with the reporter and the wider community to fix them. I don't want to sound, of course, that only Trezor is affected. There are a lot of other security solutions like Intel SGX and Secure Elements, which also they have their flaws. But I'm not really interested in their flaws because they are closed and I cannot fix them anyway. So what I will give you will be a couple of examples of how we found out about the issues and how we fix them, because that's actually doable with open design like Trezor. So what you can do is side channels analysis. Again, it was done by Jochen in 2015. And when he was reading the code, he realized it's not performing in constant time. So what it does mean is that if you have a 0 in a private key somewhere, it skips some portion of the code, and if there is 1, it performs it, and it's basically leaking some private data by how long is the code running and how much power does it use. And this was fixed in software by using constant time operations. So basically, you go through the code, and on every place where this is happening, you just replace it. And how you can replace it? It's being done like this. If there is a 0 in some bit, you still perform the operation, but then you discard the result. So the attacker really doesn't know if there was a 0 or not, because the code always runs. And also, PIN is asked before any operation with secret data. So if you would like to perform side channel analysis, you would need to know the PIN first, and then it's a problem, because it's not just some random hacker that found Trezor on the street. This was his tool. It's an oscilloscope, and he attached to the USB cable and was able to measure the power consumption. And this is written on his blog. Like you could see, like which operation takes how much time in in this time domain. Okay, so then there is a glitching. There was a talk at DEF CON this year by Josh Datko, and what he was studying was a VCC glitching. So basically what you do is you identify some critical operations, like writing the wrong pin number twice in the flash. And when this is about to happen, you decrease the voltage on the microcontroller, so it's not able to perform the write, but it's still enough voltage so it doesn't shut down. And this is called VCC glitching. So basically, you make microcontroller to skip some operations which are critical because it doesn't have enough power. And there are various ways how to fix that. So there is something called brownout detection. So there is a part of the microcontroller that is watching the voltage, and if voltage goes under some value, then it just shuts down the processor. And also, you can check for every critical operation if it really happens. So if you are writing this wrong try number on the flash, you write it and you wait after it has been written. So you constantly keep asking flash, like, are you done? Are you done? Are you done? And even you are not going further until it's not written, and then you again check, like, is there really increased number written there? So you read it back, and if there is a mismatch, you just say, there's something really fishy going on. And there is another group of attacks called clock glitching, and basically there is on microcontroller, there is usually some external crystal which ticks at some frequency. So microcontroller can work with USB and other peripherals which require high precision. And what you can do is somehow glitch this clock again, so like in a similar fashion. So microcontroller skips some instructions, but doesn't shut down completely. I will show some example. And this can be avoided by enabling clock security system. So again, in microcontroller, there is a chip which is always watching at the frequency of this external crystal. And if it goes, if it's not like 8 megahertz like it should be, but I don't know, 0.5% bigger or smaller, then it shuts down the microcontroller. So this is the tool called Chip Whisperer, which is able to perform such attacks. There is an FPGA here. There is your testing microcontroller here. So imagine this part is off, and you will attach a Trezor with microcontroller. And there is a library on the Chip Whisperer website which says, like, if I want to make this microcontroller to skip 7 instructions, perform this VCC or clock glitch, and it will jump 7 instructions, for example. So what Josh was trying to do is to perform so-called out-of-loop glitch. So basically, when Trezor is waiting several seconds, because between pin entries, we wait for some time if you manage to mess up. So this is the code that waits for a couple of seconds until it continues. Frag is the frequency of the processor, basically, and this is the number of seconds you want to wait. So we multiply the processor frequency with the seconds, and we perform this infinite loop. And if you are able to glitch this, so just skip one instruction that goes at the beginning of the loop, you can basically glitch out of this loop completely, basically eliminating the delay. But what Josh found out, that we used this code, so we have this inner loop which waits for 1 second, and we have this outer loop which waits for seconds. and it's much harder to jump out of 2 loops at once. And you can do this kind of optimizations, or it's not really optimization, it's the opposite thing. You make the core code more complicated, but for a very good reason. So I wanted to mention some political attacks. You probably know a lot about this, but I don't have a lot of time. So just in a nutshell, there are always some group which are trying to persuade you that their version of Bitcoin is better than the others. They usually use the argument, we have bigger blocks, so there is a bigger throughput of the transactions. Again, there is a lot of things that can be said about this. If you want to talk, just grab me outside, and we can talk. So just some main takeaways. So stay vigilant, educate yourself, don't be afraid to ask. Like, there are always people that are smarter than you, and they don't really behave like assholes. So don't be afraid to ask, you might learn something. And also always analyze others' people's thoughts before you adopt them. So you will learn if that's really making sense. So don't be a sheep. So this has been my talk. This is my Twitter account, my email, and probably a lot of people were thinking that this will be a Trezor 2 talk, but there are a lot of people around the Congress from Satoshi Labs, so you can ask them about Trezor. They have some devices here. You can have a look, and there is a lot of material written about Trezor on our blog, and it will be updated more and more until the Trezor is released, which will be probably the first question I will ask now. So it's going to be released in, well, not in 2 weeks, but this year, end of this year. So thank you, and I'm yeah. So
thank you very much for your talk. We have time for a few questions, so please raise your hand, and I will remember the order, and I will come to you. Please wait for the mic with your question. But before that, is Jochen sitting here? If so, could you stand up, please? So please applause for this great guy as well. So first question, yeah.
Thanks so much for the presentation. Child pays for parent, replaced by fee and support for Monero. What are the timelines?
So, So, timeline for replaced by fee and child pays for parent is soon. Like Karel, who is sitting there and laughing, has been working on improving the send dialog for a couple of weeks and months already, but he got derailed because of some other stuff like Bitcoin Cash and others. So it's really in the queue. Maybe it was already merged, but it's like coming really, really soon. And Monero, we are working on Monero right now, but or at least that's my personal opinion, we don't, I don't want to go on the internet and say, I'm working, or my company is working on Monero, because then people are asking like, eta. So we are working on it, and once it's finished, then it's finished. We are definitely not ignoring it, but yeah, that's it. I don't have ETA, so that's why I'm not saying we are working on it. There are some challenges. I know there are a lot of Monero people here, just come to me, and I will contact, or I will give a contact to a person who's probably he already contacted you, who is working on that.
Other questions? Okay, so I will use time for my question. So, could you tell us maybe some of the discussions behind the scenes in Satoshi Labs regarding the security features in Trezor? Like, for example, yesterday we discussed the thing about the mnemonic features.
Okay, so the question was like, what are some things we are cooking and are not well known yet, or? Can you rephrase the question?
Yeah, so I will what are the discussions that even in such a relatively small team, you have different opinions on the same thing?
Okay. So we are trying to come up with a different mnemonic scheme, because the current one, which I implemented with Slash 3 or 4 years ago, has some flaws. And still, I think it's a good thing to do, because basically every wallet now is using that, and so they are interoperable. But we would like to add some more features in it. And one of the features that is really critical for me is this Shamir secret splitting. So basically, during the initialization of the device, it will already give you like several sets of mnemonics you could back up, and it's really hard to do it right, because I don't want to screw that, because if you mess up with one mnemonic, then it's a problem. But if you mess up with this multi-signature scheme, that it can be even bigger problem, because you will recognize it just when it happens. And there are a lot of discussions, both public and private, and various groups of people want to put different stuff there. Like, for example, SPV implementers of wallets, they want to have a birthday in it. So they really want to know from which point of time they need to scan the blockchain, so they don't want to scan the whole thing. And some other people just don't want to have birthday in it, because they are leaking some info which probably might or might not be shared with the others. So there are a lot of points to make during this standards creation process.
Sorry, wait for the mic, please.
Yeah.
Is there a BIP number for this?
There's not a BIP number yet. I'm discussing with some of the wallet implementers first to get something, at least like a rough idea, and then we will ask for a BIP number. Another question?
Do we have other questions? So you are, of course. Oh, we have.
All right. So my question is, you say that people make mistakes when implementing protocols and things like that. So is there something like OWASP for blockchain?
So the question was, my port is, so maybe it's me who is making do you hear me? So the question was, there might be some errors introduced by protocols, and whether there is some group of people like OWASP who are working on.
So the question, if there is something like OWASP is for web application, if there is something similar in the world of cryptocurrencies, right?
Well, for Bitcoin, obviously there is this Bitcoin improvement proposal process. So there is a GitHub where these standards are being discussed and later implemented. For other cryptocurrencies, I don't know, but I would expect they have similar process like this. And when it comes to like protocols, like even abstract protocol not too tied to some particular cryptocurrency. I know there are some working groups in W3C and also IETF. And for example, in IETF, there is a working group which is trying to standardize so-called cosigners or signature aggregates. So if you have like several signatures signed by several keys, you can perform an operation which is able to create one public key and one signature, which does the same thing as a group of signature and a group of public keys. And this process also takes time. I don't know a lot about the details, but my really outsider's view is that these standards take like 10 years or even more. And I don't think that's really applicable to this kind of cryptocurrency world. But of course, it has been shown, like in my slides as well, if you don't pay a lot of attention to this protocol process, you can introduce bugs which are really hard to be spotted until they are really discovered in production, and then it's usually really late. So I don't know of any super body in CryptoSpace, but W3C and IETF are working on some cryptographical standards which can be applied in CryptoSpace or in cryptocurrency space as well.
We have time for one more question.
Hello, thank you for presentation. Have you got any thoughts about scenarios when there will be no proper replay protection during the 2x hard fork?
Well, there are some ways how to split coins even if there is no proper replay protection. And it's one trick is to use lock time, where you basically say this transaction cannot be spent before block ABC, and you submit, you create a transaction with this lock time, and if one blockchain is in advance of another, you use this higher number. So it can be mined only on one blockchain, and once if it's mined there, you will create a double spend transaction on the first chain, which will send it to another address. But that again, it's doable, but it's not like super easy for regular people. So if there was a proper replay protection, strong one, it would be much easier. Like Bitcoin Cash, they implemented this strong replay protection a couple of days before the fork, and it was not the fork was not flawless, but at least there was not a problem with that. So there are a couple of ways how to do it, but again, I don't want to say like we do it that way, because maybe tomorrow they will create a strong replay protection, and again this statement would be like of no use anyway. Okay, so thank you very much.
Thank you very much for your questions, for your answers, and in the first place for your interesting talk.
Yeah. Yeah.